Okay, so this type of problem is sometimes referred to as a work problem. It's a really common setup where they'll tell you how much each person or each thing can do individually. So it might be like a machine that's making photocopies or a person who's painting a room. And they'll tell you how much the first thing can do on its own, how much the second thing can do on its own, and then they'll want you to put it together and say, okay, if they're working together, how long to do whatever, right? And it's not a very, like, it's a weird problem and it's not an easy one to solve, but there is a trick to it that will work every time. So when it tells you in this problem that Michael washes 1 car in 2 hours, what we want to do is get to a rate that we can compare. So comparing 2 hours and 4 hours, instead of doing that, we want to talk about how much can each person do in 1 hour. So if Michael can wash 1 car in 2 hours, then if you were going to think about, okay, cutting that in half and only doing for 1 hour, how much of the car could he wash? He could wash 1/2 of a car in 1 hour, right? And so the nice thing about it is that whatever the number is, as long as this number is 1, whatever this is, it'll become your denominator. So then Jim washes 1 car in 4 hours. So then in 1 hour, he could do 1/4 of a car. Okay, so that's the first thing, is to get like your combined info. So now, if they're working together, we can take these two amounts and we can add them. So in 1 hour, if Michael's doing 1/2 of the car, and Jim is doing 1/4 of the car, we can add those together to figure out how much they can do together in 1 hour. To add fractions, remember you need common denominators. So for this one, I'm going to multiply both the top and the bottom by 2. So that gives me 2/4 plus 1/4. And so together they can do 3/4 of a car in 1 hour. Okay, so now you're going to look at the question and you say, okay, if they can do 3/4 of a car in 1 hour, what we're trying to figure out is how long it will take them to do 2 cars. So one way to think about this is 1 car here. If we're saying that they can do 3/4 in 1 hour, remember that 4/4 represents 1 whole car. So then if I multiply that by 2, 8/4 is going to represent 2 cars. So then what I can do is I can take this 3/4 and I can just start adding them to figure out at what point do I get to 2 cars. So if I say, okay, 3/4, that's how much they do in 1 hour, plus another 3/4, that's going to be for the second hour. So right now I have 2 hours. And if I add this up, 3 plus 3 is 6. So right now they can do 6/4 in 2 hours. If I add on another 3/4, so now I'm up to 3 hours. 6 plus 3 is 9/4. Remember, I only had to get to 8/4. So this is actually a little bit over what I needed. So I know that my answer is going to be somewhere between 2 hours and 3 hours. And if you look at the answer choices, I think one of the answer choices was like 2 hours and 40 minutes. And so that would be the correct answer. So just to recap those steps again, you take whatever their individual information is and you figure out how much of it could they do in 1 hour on their own. Add that together to figure out how much they can do together in 1 hour, and then work to figure out how many hours it would take to get to whatever number of cars they're looking for. So in this case, it was 8/4. If they had to do 3 cars, it would have been 12/4, and I would have kept adding until I got to 12, and so on. So again, these types of problems are called work problems usually. If you wanted to Google and get some more practice on them, you can. They're probably one of the more difficult questions you can expect to see on this test. So it might be a good idea to practice 1 or 2, but at the end of the day, like, it's only going to be 1 question. So if you don't get it, it's not a huge deal, but I think you can get it if you practice it. Okay, let me know if you find some examples and you want to go over them, or if you want me to find you some examples, I'm happy to do that also. Just let me know.